I wanted to give you more examples of the use of quantifiers that we find in section 2.4 of our text. And I thought I would use hopefully an example that you can identify with. We can have open premises, open statements with two variables. And so this would be a premise with two variables, x and y. And here you go. This is the first one. So here we have triangles x and y, and this first premise is that they are congruent. Second one is also going to be for x and y, and you're probably familiar with this statement. Corresponding angles of x and y are congruent. Okay. So one of the true statements that we can say is that for every set of triangles, x and y, if triangles are congruent, then the corresponding angles of those triangles are congruent. Okay? That is it's called the universal implication. Alright, now we've talked about the inverse, converse, and contrapositive. Let's think about, if this is the implication, let's think about what the contrapositive would be. And hopefully you recall that the contrapositive is reversed and negated. So that would be for every pair of triangles x and y, if it is not the case that the corresponding angles of triangles x and y are congruent, then it is not the case that triangles x and y are congruent. Okay? Let me run you through a couple of examples again with the negating. First of all, let's negate the universal implication, the first one we started with there. So what we're doing is we're negating our first statement for every pair of triangles x and y if the triangles are congruent, then corresponding angles of those two triangles are congruent. To negate this, okay, it helps to recall, and it always helps me to just put this over to the side, that the implication is logically equivalent to not P or Q. It always helps students to just, you don't have to worry about me getting that messed up again like I did in class last week. Just get it here so that it's clear for you and me. So this statement here, again, these are like the application of the De Morgan's law. The negation of, if it's not the case that for all x and y triangles then that means that there's at least one pair of triangles x and y where it is not true that when two triangles are congruent, then you have corresponding angles of x and y that are congruent. Okay, and now we can take this in to these brackets, and I could have went ahead and replaced the implication with the disjunction, but we can do that here. There exists at least one pair of triangles. Can we do this in one step? We want to negate this not P or Q. So negating not P or Q is going to put a double in front of P, which is going to make it P, and then negate this is not Q. So distributing the negate across this is going to be P and not Q. So, and not. Okay, so if we're saying that it is not the case that for every triangle pair x and y, if the two triangles are congruent, then corresponding angles of those two triangles are congruent. That's equivalent to saying, again, if it's not the case that all pairs, then there exists at least one pair such that the triangles x and y are congruent, and it's not the case that corresponding angles of x and y are congruent. So that would be the negation of the universal. All right, one more. Let's negate the contrapositive, the universal contrapositive. Okay, here we go. You know what that means. All right, so the universal contrapositive that we're going to negate for every pair of triangles x and y if it is not the case that corresponding angles of these two triangles are congruent, then it is not the case that the two triangles are congruent. Okay? Again, if it helps, P implies Q is logically equivalent to not P or Q. So we can distribute this and say, well, if it's not the case that every pair of triangles x, y behaves this way, then what that means is there exists at least one pair of triangles where it's not going to happen this way. The negation of this, okay, we're going to negate the first and leave the second alone with an or. So if we negate this, that's going to make it a double, so back to just qxy, or, and leave the second as is. It's going to be not p of x, y, boom. Now we didn't distribute this yet. All we did in this case was switch it from the implication to the disjunction. So now we're going to distribute this guy, this negation out here. So for some pair of triangles xy, what's happening is it is not the case that corresponding angles of triangles x and y are congruent, what happens? And the triangles themselves are congruent. Okay, so you could actually, these are commutative, so you could turn this around. So we could say it this way. If it is not the case that for every pair of triangles x and y, if the corresponding angles of the triangles are not congruent, then the triangles are not congruent. That is equivalent to saying that somewhere out there you can find a pair of triangles such that, and we'll go ahead and say it in order, such that the triangles x and y are congruent and the corresponding angles of x and y are not congruent. Okay, so that's the negation of the contrapositive. And wouldn't you know it, the negation of the universal implication and the negation of the universal contrapositive. What do we end up with? P of xy and not Q of xy. This is commutative, so we can write that as P of xy and not Q of xy. Okay? That's just a little more practice. What I'd like for you to do out of 2.4 for homework, and we can discuss this. I still like to have the test on Friday if possible, but we can look at this on Wednesday. Out of 2.4, what I'd like for you to do is 4, and start with A and then do every other, so A, C, E, and so forth. 8, do the same. Start with A and then do every other on that. And then 14, 18, and 20. On 20, just do A and B. Don't worry about C. Okay? Hope that helps you guys. We'll see you on Wednesday.